Hello. So in this video, we're going to be doing sort of a quick overview of intercepts and sort of what they are sort of visually and some notes about them sort of analytically. So visualizing intercepts. So intercepts in a graph, they occur when one of those dependent or independent variables, one of those is 0. So in a graph setting, that would be when either the sort of x value is 0, which corresponds to a y-intercept when x is 0, and then the x-intercepts, which correspond to when the y is 0. So, and it's worth a mention that's sort of backwards of what you might expect, right? But it's because when the y is 0, which we can see here, right, that's the vertical distance, which means we're hitting the x-axis. So that's why they're sort of opposite of what you might expect. So here we have 3 points where it's hitting axes. The A, B, and C, each of these are x-intercepts. But noteworthy is that B is hitting the x-axis, but it's also hitting the y-axis, which is why B is also a y-intercept, meaning that you can have the same point be more than one type of intercept, okay? Some sort of reasoning through should tell you that there's really only one of those points that it could do that on. So I'll leave you to that to think about and take a look at this and see if you can figure out why. So another example, so here again, A, B, and C. A and C, these are x-intercepts because they're where they are hitting the x-axis, which again is when y is 0. And B is going to be our y-intercept because it's where it's intercepting the y-axis, but that's when x is 0. Okay. So a couple notes about computing these things sort of in practice. The y-intercept, always easy to compute. And the reason why is that the y-intercept is occurring sort of where that x is 0, and where x is 0, you can just plug in to your function, right? Functions are designed to take in x values. You know the x value, plug it in and compute. So it's at least straightforward, if not always easy, depending on how gross the function is, but it's sort of very straightforward to do. In contrast, the x-intercepts can be pretty tricky to compute. And in fact, there's like a whole bunch of different techniques in order to actually find x-intercepts. And which one works depends on what the function is that you're trying to find it in. In fact, fun fact for you, one of the longest standing sort of $1 million prize, which is an actual thing, problems in mathematics. So if you could solve this in math, you'd win $1 million, which would pale in comparison to how much people would pay you to talk about how you solved it. That question is finding the x-intercepts of a function, explicit function that is written down, and yet we can't find the intercepts. It can be that hard. So as we go through the rest of the semester, we're going to be discussing some specific techniques that work on specific types of functions. That's what a lot of that deep dive for each function type is about. But keep in mind that that's the whole thing. X-intercepts can be very tricky. Y-intercepts, nice and straightforward. X-intercepts, almost always annoying. Okay. So what did we do? Well, we talked about what intercepts were, right? We talked about what an x-intercept was, what the y-ones are, or y1, because there's only sort of the one, and what they look like on graphs, right? So we looked at some graphs, pointed out where the x and y-intercepts were, and we talked about sort of why the y-intercepts might not be so hard to find, or at least straightforward to find, but the x-intercepts, those can always be very tricky. So we have to sort of develop specific techniques moving forward. Okay. So that is that.